on this. And then we're going to share screen. And guys, have you ever seen a bar graph before? This is called a bar graph. And a bar graph will show us how many hours were Jason, Kathy, Erica, Bill, and Jack worked on this farm. And it's an apple farm. So if you look at this bar graph, you can see Erica is worked these many hours. Jason, Kathy, Bill, and Jack. How many hours did Erica work? And raise your hand if you want to share that. How many hours did Erica work? And one of the really good things to do is take your little eye and bring it from the top of Erica's bar all the way across to what's called the vertical axis. And you can see that it's somewhere between 25 and 30. Eleanor, what do you think the answer is?
28.
Wow. Jason, do you agree with that?
Yes.
Great, great. So 28 hours. And the next question, and Jason, I want you to answer this one. How many hours did Kathy work?
She worked 12.
Oh, very nice. Now, was that Jason that said 12 or was that Eleanor?
Jason.
Jason, great. Jason, could you leave your yourself unmuted? Because that way I know when you're speaking and I can hear you right away. So if you would leave that unmuted, I'd really appreciate it. Fantastic. So yes, so Kathy worked 12 hours. And now the last question is, how many more hours did Jason work than Jack? So, oh, hi, Valerie.
Hi.
How are you, honey?
Good.
Good. Great to see you. Great to see you. So how many more hours did Jason work than Jack? And so you got Jason's bar, and then you've got, so Jason's bar goes across to here, and Jack's bar goes across to here. So who wants to take a shot at it? Valerie, do you want to do that? We figured out that Erica worked 28 hours because her bar goes all the way up to 28. And we found out that Kathy's goes up to 12 hours. She didn't work as hard. But the question now is, how many more hours did Jason work than Jack? So Valerie, I'd love for you to take a stab at that one. Valerie, are you going to try to help us, honey? Just let me know that you're working on it because I can't really hear you.
Jason worked 25 hours.
That's correct.
Jack worked 16 hours.
That's right. Oh, hold on. Jason, you cannot speak when Valerie is speaking. Okay, you never speak when another student is speaking at the same time. So Valerie, go ahead, honey. So how many more hours did Jason work than Jack?
9.
Wow. And how did you come up with 9?
25 minus 16 is 9.
Wow. That was awesome. Now, Eleanor, I want to ask you, how many more hours did Erica work than Bill? How many more hours did Erica work than Bill? So we have Erica,
7.
versus Bill.
7.
So Valerie, are you trying to work on this on your own, honey? It's really important that you're able to do that.
$21.
21. Wow. And what mathematical sentence did you do to accomplish that?
28 minus 7 equals 21.
Wow. That was awesome. That was awesome. And now, Jason, I want to ask you the same question, but I really want you to compare to other people. So I'd like you to tell me about Jason versus Kathy. So Jason versus Kathy. So can you tell me that, Jason, since you are Jason? And you'll have to speak, Jason, because I'm not sure exactly what you were showing me. But we're looking for Jason versus Kathy. Jason versus Kathy.
50.
Can you say the number sentence that you had to create, please?
25 minus 16 equals.
I'm sorry, I can't hear you, buddy.
25 minus 16 equals 14.
You said it was 13 before, and Kathy worked how many hours? In fact, you're the one who answered that before. So it's 25 minus what? You want to help out, Eleanor?
12.
Right. Remember, Jason, that Kathy worked 12 hours? And 25 minus 12, Jason, is what? Jason, are you trying to find out the difference between 25 and 12, or are you working on something else? Jason, can you let me know? No, you can't show it to me. You've got to say it out loud. That's really important. 13 is correct. Very, very nice. Very, very nice. Now, I'm going to show you guys something really cool. So this week, 2 days ago on Thursday, was a very special day. And that day was December 2nd, 2021. Now, the number 12 is there to represent which part? Eleanor? Eleanor, why is there a 12 in the date? What does the 12 relate to? We know that the 2021, so 2021 is the year, 2 is the day of the month, and 12 is the actual month. Now, can anybody tell me why this is a special number? Valerie, do you see anything interesting about this number? Jason, I'd love for you, Jason, to look at the number because that way you can analyze to see if there's something special about it. And Valerie, do you want to share with us?
Wait, which number?
Well, the number that I wrote on the page, which is 12/02/2021, which is the date from 2 days ago, that was Thursday. Do you notice anything special? And Eleanor, you seem to have something that you want to share.
It's my dad's birthday.
No, are you kidding me? Okay, so this is Eleanor's dad's B-Day. And please wish him, Eleanor, a happy, happy, happy birthday for me. Now, we know that your dad is very special. And also 20 million people around the world celebrated their birthday as well on December 2nd. But guys, Valerie, are you looking at that date? Jason, are you looking at that date? What is so interesting about it? Go ahead, Valerie.
Wait. Both, the starting and the ending both are ones, and the second to last and the second one are both twos. The third to last and third are both zeros, and the fourth to last and fourth are both twos.
Wow. And does anybody know what that means? Jason, I know that you're trying to figure it out. What does that mean? Does anybody know what that's called? Valerie, it has a special name. Do you know what the special name is? Anyone? It's called are you ready? Palindrome. And a palindrome is a number or a word that is the same backwards and forwards. Eleanor, can you read it to us forwards from left to right, please? Starting with 1, go. 1, 2, 0, go.
100.
Well, just read the digits, honey. Just read the digits. 1, 2,
0, 0, 2, 2, 0, 2, 1.
And Jason, can you read it from right to left, please?
1, 2, 0, 2, 2, 0, 2, 1.
And guys, because it's the same both ways, it's called a palindrome. But there's something else that's even more special. Now, are you guys going to watch this? I'm going to actually change it. I'm going to put it down over here. And I don't know if I can do this, but I'm going to try to change the color. Let's see if I can do that. Properties. And don't know. No, I don't think I can change the color. Okay, you guys ready for this? Watch what happens when I spin it. Are you ready? You're not going to believe this. You're not going to believe this. No. Wait, is it still 12/02/2021? And do you guys know what that's called? That has a special name, and it's called an ambigram. Everybody say ambigram.
Ambigram.
Ambigram. So what kind of numbers are ambigrams? Like just a digit. What number or digits would be an ambigram? It doesn't have to be also be a palindrome. Do you guys know any numbers that are ambigrams? Go ahead, Valerie.
11.
Oh, wow. That was a great choice. And everybody watch what I'm going to do right now. You ready? Jason, you got to look up. You know what? Valerie is 100% correct. 11 is an ambigram. Who can name another ambigram without using all ones? Because that one was very clever. We say bellissimo. Actually, my friend taught me that word, and it means very clever. Go ahead, Eleanor.
22.
22, but we have to write it in block writing. And let's see if it works. You know what? I didn't write it fast enough, but I'm going to try it one more time here. Let's see if I can do this. Let's see. Ah, it worked. There we go, Eleanor. Yay. It worked. It worked. Can anybody give me something without using the numbers that are in this ambigram here? So different digits to make an ambigram. Jason, do you want to try? Jason, do you want to give it a try, buddy? Is that a yes or a no? Give me thumbs up or thumbs down, or speak. Okay. And Valerie, do you have another one? Go ahead.
55.
Wait a minute. 55. Whoops. I can't, I have to do it in block, correct? Let's see. And let's see if it worked. Oh, it didn't work. But we can see that the number 5, the digit 5 is an ambigram in itself. Eleanor?
99.
Oh. Now, let's do 99. Okay, I didn't like the way I made my 99. Let me try again. I'm going to make it in block. And let's see if 99 is in fact an, uh-oh, what, Eleanor, what just happened? Did those 9s turn into 6s? Wow. So we know, wait a minute, guys, can we fix what Eleanor just did to make it work? Who thinks we can fix it? So Eleanor had said 99, but that's not an ambigram because it makes 66. But what about Valerie?
88.
88, yes, that's true. But can you fix what Eleanor just did with 99 to make it work? Jason, any ideas? Just a little change, guys. Are you ready? Watch what happens when I write the number. What number is that?
6.
What number is this?
96.
And now watch what's going to happen, guys. Hold on a second. Now we're going to make 96 a little smaller. Grab it, bring it down, and watch this, guys. What does 96 become when we spin it around? Are you watching, Jason?
Yeah.
Oh my gosh.
96.
So either 96 or, come on, guys. Come on, Valerie. Come on, Jason. Come on, Eleanor.
69.
Right. 69 would be the same. And Valerie, I'm also really excited to try 88. And I don't know really how to draw a block 8. Maybe, would that just be a block 8, guys?
Yeah.
Wow. Those are really, really cool. So remember, what are those called again?
Anagram.
Ambigrams. And what is a number that's the same both ways?
Palindrome.
Palindrome. A palindrome. Now, I was wondering if we could try something. Everybody write down the number 138.
Right.
Now, I wanted to ask you, is 138 a palindrome? And Jason, I'd like you to be looking at the screen. So when I ask you a question, you can actually be analyzing what I'm asking you. I'm not sure what you're writing right now, but can anybody tell me, is 138 a palindrome? Would anybody like to answer that question? Who would like to share? Okay, go ahead, Valerie.
138 is not a palindrome.
Right. Would you guys like to turn it into a palindrome? Would you guys like to try that? Okay.
Yeah.
I want everybody to write down the reverse of 138. Jason, I'm going to ask you first because I want you to be engaged in what we're doing here. So can you reverse the digits of 138, Jason, and say that out loud?
3 digits.
Can you please reverse the digits, please? Say them in reverse order.
138.
Well, that's the correct order. That's the way I wrote it, 138. Can you say it in reverse order?
8 plus 3, 1.
All right. Everybody write that down right now. 138 and 831. Now, I want you to add those numbers together, please. Don't say it out loud. All right. So I'm going to go with Eleanor. Can you tell me what the answer is, please?
969.
That is correct. And is that a palindrome, guys? Valerie, is that a palindrome? Valerie, is that a palindrome?
Yes.
Yes, it is a palindrome. So guys, we were able to do that in one step. Now, the next number I want you guys to write down is the number 164. Everybody write down the number 164. And then write the reverse of that number below 164. So Eleanor, can you say that out loud? What number is the reverse of 164?
461.
And now, can everybody add it? And the person who answers is going to also have to say whether or not it's a palindrome. All right, go ahead, Eleanor. Because I can't see you, Valerie. You're kind of out of the picture. So if you could maybe angle the computer down, that would be awesome. All right, go ahead, Eleanor.
That's 625.
625. Weren't you supposed to tell me if that was a palindrome?
Yeah.
Is it a palindrome?
No.
No, it is not. So Valerie, can you tell me the reverse of 625? And Jason, I'd like you to look at the screen so you can see what we're doing too.
526.
Everybody add that up now, everybody. And Jason, I want you to tell me the answer and then whether that answer is a palindrome.
625 plus 526.
And Jason, can you say it out loud?
1151.
Jason, is that a palindrome?
No.
Say it louder, please.
No.
So Eleanor, do we have to do this again? Can you reverse the digits? Go ahead, Eleanor. Go ahead, Eleanor.
1511.
And now everybody add those two numbers up. And I think you guys are going to see a big surprise. And who would, Valerie, would you like to share?
Yeah.
Go for it.
2 2 2,662.
Oh my, guys, is that a palindrome? Yes.
Yeah.
How many steps did that take? And we could just count the plus signs. How many steps was that, guys?
3.
That's right. Now, I'm going to give everybody a challenge right now. Would everybody like a 3, 4, or would you guys like a 4-step number?
Yeah.
Okay,
Yes.
here we go. And Mr. Kramer's going to work on a 23-step number. Yeah, I know. 23 steps. Okay. So I'm going to give the number 174 to Eleanor. I'm going to give the number 175 to Jason. And I'm going to give the number 183 to Valerie. So again, Eleanor, you're 174. Jason, you're 175. And Valerie, you're 183. All right, go. Your job is to tell me what the answers are to those palindromes. And let me know when you have your answer. Eleanor, what is your original number?
174.
Jason, what was your original number?
100.
What was your original number, Jason?
120.
No, your number was 175. Your number was 175. So you should redo it if you did not use 175. What about you, Valerie?
183.
Okay. So I want you guys working really, really hard to try to find the actual palindrome that's created by these numbers, because almost all numbers will create these beautiful palindromes.
I'm done.
You're done? Okay. Eleanor, why don't you give yours first, and then Valerie's going to give hers.
$5,115.
So say it one more time, please.
5,115.
5,115. Wow. That is a beautiful, beautiful palindrome. How many steps did it take you?
4.
4 steps. So I'm trying to do your number, and it is really, really interesting. So 1, 2, 3, 4 steps, 5,115. And Valerie, what did you get for your special number?
13,431.
13,431. Wow. That is a really, really cool number. And I'm just going to check your work really fast. Valerie, tell me if I'm doing everything correctly, please. And if I'm not.
It's 180. Wait. Oh, yeah, that's right. That's right.
Okay, cool. And let's keep going. And that's not it. And 9201. And it looks like I'm going to have to go one more step to 03201. And oh my God, Valerie, you did it also. Great, great work. And Jason, are you going to come back and are you going to tell us what you got? Jason, are you with us, buddy? There you are. So Jason, what was your answer?
686.
686. So 175, 571. Now, Jason, does that number look too small? Because when I do my first calculation, Jason, can you please unmute yourself like I asked you at the beginning of class, please? And Jason, look at me in the eyeballs, please. Jason, Jason, stop hitting the mute button. Can you give me a thumbs up if you agree to that? Okay, awesome. Now, Jason, is 686 a possible solution?
No.
No. So, Jason, what did you do? Did you add 175 to 571? Does anybody want to help Jason, guys? Jason, do you want to tell us what that is? Jason, stop hitting the mute button, please. I know I've asked you before, but I'm going to ask you again until you stop. That would be awesome. Oh, you hit it again. All right. And Jason, is there any way you could tell us what 175 plus 571 is?
170.
170?
Yeah.
No, I don't think so, buddy. Buddy, what is 5 plus 1, Jason?
1.
5 plus 1 is 6. What is 7 plus 7?
14.
And when we carry the 1, 1, 1, and 5 make what? Come on, Jason. 1 plus 1 plus 5.
Oh, 7.
7. And so what are you going to do next, Jason?
No. To add more.
Keep going. What are you going to add, Jason?
740.
Go ahead, Jason. What are you going to add to 746?
148.
No, you're going to add the reverse of 746. And what is that, buddy? Eleanor, do you want to help him?
Yes.
Okay, what's the reverse of 746? And
147.
647. Jason, do you see how 647 is our next step? Because that's the reverse of 746. Do you see that?
Yes.
Okay, can you take your hand away from your mouth? Because then I will be able to hear you really well. Thank you.
Yes.
Thank you. Now, can you add those two numbers, Jason? Can you write them down, please? Everybody else is writing them down. Valerie, are you writing them down?
Yeah.
Great. Yeah, I'm not sure what you're doing, buddy, Jason, but you got to get involved in what we're doing and stop hitting the mute button, please. Valerie, if you want to tell me the solution, and Jason, can you say it out loud, buddy, with your words?
I know what the palindrome is.
Awesome. Jason, I'm really trying to get you to engage with us here. Jason, can you read the answer to that addition problem? Okay. Valerie, maybe you can help us. What's the answer to this addition problem?
That one. Wait, is it? $1,393.
1,393. Jason, is that what you got? Jason, is that what you got?
Yes.
Great. Now, Jason, can you reverse those digits, please? Jason, can you please reverse those digits for me?
136.
No, sweetheart, come on. We're going to reverse the digits. What it means, Jason, is we take the last digit first. That's a 3. The next digit is a 9. Then a 3. And then a 1. So what we've done is we've reversed the order of the numbers. Now, Eleanor, can you tell us the sum of that? And Jason, I would really love for you to do this work. I'm not sure what's going on today, but it would be awesome if you could get involved in what we're doing. Go ahead, Eleanor.
1,324.
Say it one more time, please.
1,324.
I don't think it can be that because we're adding 1,393 and 3,931. So it must be way bigger than 1,000. If anybody else wants to help out, that would be awesome. Jason, I'd especially like you to answer this question because I know you can do this with your eyes closed, probably.
532,004.
Okay, you'll have to say that number again, please.
532,004.
5,324. Can you just say the digits, please?
5324.
5,324. Now, Jason, the way this number reads, if you can look at me, please, is 5,324. Can you say that out loud, please?
500.
No, not 500. The 5 is in the thousands place. Say 5,000.
5,324.
Very, very nice. Now, Jason, can you reverse the digits, please?
3,024 plus 3,000.
I cannot hear you, buddy. You're going to have to speak up. I want you to reverse the digits of that number. Please.
5,034.
No, buddy. It's reversing the digits. Do you know what reverse the digits means? If you don't know, say, Mr. Kramer, I still don't get what you mean. And it's okay. It's okay. Do you not know how to reverse the digits? Jason? Jason? So, Jason, look at me in the eyes, please. In the eyes. Jason, can you read this number backwards, please? Read it backwards, just the digits.
400.
No,
4,235.
4,235. Excellent. Now read it as a number, Jason.
50,324 plus 400.
4,000.
4,023.
No. 4,235. 4,235. And Valerie, what do you get for a solution?
This one. 9,559.
Wow. And that was Jason's palindrome. What a beautiful, beautiful palindrome. Now, guys, I have something very special for you. I made a worksheet for you where you can find the palindrome for all the numbers from 1 to 200. Now, there's a very special number out there that takes 23 steps. And the number is, are you ready? The number is 187. It takes 23 steps and it becomes a palindrome. Would you like to do the first few? Everybody, watch this. Just don't even write. Put your pencils down, and I want to see all your faces. Okay? So I've got Eleanor's face, I've got Valerie's, and I've got Jason's. Are you ready? Step 1. Step 2. Now, guys, do you realize that this has 23 steps? Is that crazy? But it really works. Now, let's say that you want to share this with your parents or a friend. There's a very, very special number that will never, ever be a palindrome. Valerie, I want to see your eyes, please. Now, this is called a Lycral number. So a Lycral number, and I want to see if I can spell that properly. A Lycral number is a number that will never be a palindrome when you add the reverse. And are you ready for the first Lycral number?
Yes.
It is 196. So I tried this about 100 times and it does not work. And then I found out that people have actually tried this with a computer, 1,000,000 steps. And Jason, I'd love to see your face so I know you're listening. People have tried this number, 1,000,000 steps, 1,000,000, and it still doesn't work. So would you guys like me to share with you my challenge sheet, which allows you to find all these great palindromic numbers? Would that be fun? Now, I want you guys to all choose right now a 3-digit number. So Eleanor and Valerie and Jason on 3. Eleanor, 1, and Valerie and Jason, get ready. Go, Eleanor.
111.
They have to have different digits because if otherwise it's a palindrome to start with no steps. Go ahead, Valerie, you do yours.
123.
Find me the palindrome. Jason. Eleanor. Eleanor, what's your new number? Come on, Eleanor, I want you to choose a new number, please. Eleanor, can you please choose a 3-digit number with different digits?
243.
Okay, start with that one. Jason, go. Come on, Jason.
122.
122?
Yes.
Okay, all right, get going, guys. Valerie, do you have your palindrome yet?
Yes.
Go for it.
444.
Oh, wow. Now, Valerie, choose another one while Eleanor and Jason are working on theirs. And Jason, you're going to need a pen unless you're ready to give your answer. Go ahead, Eleanor.
I'm doing my second one.
Okay, go for it.
85.
585. That's awesome. Jason, what about yours, buddy? Jason.
126.
What about what did you say, buddy?
126.
I can't hear you. If you sit up straight and maybe look into the camera.
126.
No, when you reverse the digits, buddy, it's 221. And when you add them, the middle number is a 4, 343. So Jason, you really have to practice during the week. And Valerie, did you get another one?
Yeah.
What was your other one?
848.
Yeah, but that's a palindrome already. That's a palindrome already. So guys, I hope you have a lot of fun with this. I won't be sending it for a little bit, but maybe within the next half hour, you'll get it. And you can start to work on all of these wonderful, wonderful numbers. But do not choose 196, because if you do, you'll never make a palindrome. Ever. Well, maybe after 1,000,000.
I'm gonna choose 200.
All right. Bye, guys. I'll see you next week.
Bye.
Bye.